Hello, algebra students. Mr. Laurence here, and we're going to learn about arithmetic and geometric sequences today. Now, this is something you actually already kind of know. Now, you got to listen to this. Justine, are you paying attention? You see these big formulas here? In the past, some of you would get scared and hide under the covers or under the desk at a problem like this. Do not do that. These are simple things, and you already know how to do them. You might not know how to use these formulas, but formulas are just plug and chug. All right? An arithmetic sequence, if it were to be written as a function, would end up being a linear function. Yeah, that's all it is. It's a linear function expressed a different way. We're not talking about functions, we're talking about the sequence. And the nice thing about it is it can be quicker to find the term you're looking for using the arithmetic sequence. Okay? Now, a geometric sequence, you already know too. The geometric sequence is the one we learned on Thursday and Friday. It's when the pattern is exponential. And it'll be less work to find the term you're looking for if you can recognize it's a geometric sequence. Okay, now I'm going to go through and I'm going to define these terms for you here, this a sub n and a sub 1 and all this. Okay, they're no big deal. First of all, a sub 1 is just the first term. Oop, not the first term, sorry. The first term. All right, you got that, Kaylee? It's just the first term. So if you look at the sequence down here, this 3, 7, 11, 15, 19, the first term is 3. A sub 1 is 3. Okay? D is easy. It's the first differences. Yeah, the first differences. Remember when you would make a table? Okay, for this, for geometric and arithmetic sequences, you're not going to make a table. All right, D is just going to be the first differences. All right, N is just the number we're counting to. The number we're counting to, the term we're going to, the term we are counting to. And this is very important. That means that n minus 1 is the term before it. Yeah, it's just the term before it. Okay, now this is the last term. Oh, excuse me, I shouldn't say last term. It's the term we're counting to. The term we're counting to. We are counting to. All right, let's go and see how this is used. All right, now in the past when you had an arithmetic sequence, and you may still have to do this, because you notice I didn't mention quadratic, cubic, or quartic. If your series of numbers is one of those, these don't work. Okay, arithmetic works when it's a linear sequence, a linear function, excuse me, and geometric works when it's a exponential function. But let's go down here and see how this works. All right, we've got 3, 7, 11, 15, 19, and we're told to find a sub 30. Well, first thing I'm going to do is write down this formula. A sub n equals a sub 1 plus d times the quantity of n minus 1. I'm going to fill in everything I can. All right, I don't know a sub n, but I'm looking for a sub 30, so that's going to be a sub 30. That's what I'm looking for. I don't know what it is. I'm going to figure out the 30th term. A sub 1 is 3. D is the first difference. Well, it looks like it's plus 4 all the way across, right? That would make it linear. The first differences have to match, so the D is going to be a 4. Now, this is the easiest part of the whole problem, but sometimes kids get confused. You see how 30 is sitting in n's position? This is 30 again, 30 minus 1. Now, very careful. Are you listening, Mr. Nice Wander? Mr. Reed, very important here. You've got to follow your order of operations. You have to do the parentheses first. Now I have to multiply. So I have 3 plus 4 times 29. Well, 4 times 30 would be 130. 1 plus 4, I think it's going to be 126. Yeah, 126. And then 3 plus 126 is going to be 129. So that means that a sub 30 equals 129. Okay, that's kind of like if you wrote the function for it and then you found f of 30. It's the same thing. That's all we're doing. Except it's a little bit less work because I don't have to make the whole table and write the equation and do the test line and all that. Now, all that other stuff I showed you works for all the functions: linear, quadratic, cubic, quartic, geometric, or exponential. But this one works, it's like a shortcut in a way, for linear and for exponential. All right, let's go down here and do this other red one. Same thing. I'm going to start with that formula, and I'll tell you, write this formula down a couple of times, and then you'll remember it, and you won't have to write it anymore. And fill it in. So let me see this. This is going to be a sub 200, right? A sub 1 looks like it's 6. The d, the common difference, looks like it's minus 2, right? That's minus 2. And then I'm going to have 200 minus 1. Where did I get the 200 from? Because this is sitting in nth position, so that would be 200 minus 1. All right, so a sub 200 is going to equal 6 plus negative 2 times the quantity of 199. Follow the order of operations, super duper important. Okay, I'm going to drop that plus out of there because it's unnecessary. If this was 200, it'd be 400. It would be 1 less. So 1 less 2, so 398. Right? I feel like I made a mistake there, but 2 times 200 would be 400. This would be 1 less 2, so I'm 2 less. Yeah, that's good. All right, so then 6 minus 398 will be a negative 392. That is a sub 200. Pretty easy stuff. All right, the geometric sequence is done very similarly. We're going to label, this is the term we're counting to. Term we are counting to. This is the first term, just like in the other expression. Okay, this n minus 1 is going to be the term before. The term we are counting to. Okay, and then R is what we call the common ratio. Common ratio. Remember in the exponential we found things that were being multiplied, the differences were being multiplied? That's a ratio, okay? And we're going to always use a fraction or a whole number here. What's going to be the common ratio? So let's see how this one works. Very similar. So let's see, I've got my a sub n equals a sub 1 times r to the power of n minus 1. And I need to find a sub n, so that's, or a sub 9, excuse me. A sub 1 is 8, and r is going to be 1/2. Yeah, because you're going to say, oh, I divide by 2, right? But dividing by 2 is the same as multiplying by 1/2. Yeah, you guys should remember that. We always want to express it as a multiplication problem with a fraction or whole number. So we're going to say multiply by 1/2. Multiply by 1/2. Yeah. So I'm going to put 1/2 and I'm going to raise it to the 9 minus 1 power. All right, so a sub 9 is going to equal 8 times, now this will be 8 up here, so 1 to the 8th is 1, and 2 to the 8th is going to be, let me see, 5 is 32, 64, 128, 256. Okay, so what I really have here is 8 over 1 and 1 over 256 being multiplied. Well, I'll do my little Wonder Woman thing. Let me get a blank page. 8 over 1 times 1 over 256. You remember the whole Wonder Woman thing. I know 8's going in here. I know 8's going in here. Let me see. 256. Let's see. Divide by 8. It's going to go 3. That's going to be 24. 16. It's going to go 2 times. 32 times. So 8's going to go into 8 once. It's going to go in 256 32 times. Okay, so you're going to get 1 over 32. Now, if you did this on the calculator, let me get my calculator up here and show you how you would have done it there, because you'll be doing these on the park. Yeah, arithmetic and geometric sequences will be on the park. And what we'll have here is we'll have 8 times, and then put your fraction in parentheses. Don't ask me where the fraction button is. It's a division symbol. All right. Now when it does this, it's going to give you a decimal. See that big ugly decimal we have there? All right. And then you remember you hit the math key. See the math key right here? And then frac is number 1. You have a choice. You can hit number 1 or you can hit enter. And then you hit enter again. And there you go. 1 over 32 is the answer. And look at that. I got 1 over 32. Okay. So a sub 9 was going to equal 1. A sub 9, not a sub 9, excuse me, over 32. It means the 9th term, if I keep going like this, okay, we got what, 8, and I cut in half, and I cut in half, and I cut in half, and that's the 4th term, right? This would be the 5th term. The 6th term would be half of a half. The 7th term would be half of a 4th. The 8th term would be half of 1/8, and the 9th term would be half of 1/16. And there you go. Okay, I tried not to go too big because the decimal gets really small and then the fraction's harder to work with and people don't understand it and the calculator won't show it. Okay, so here's another geometric one. All right, first you got to figure, well, let's write down the formula. A sub n equals a sub 1 times r to the power of n minus 1, right? And the first thing I need to do is fill in everything I can. Well, I know that a sub n is a sub 10. That's what I'm looking for, right? That's the one I'm counting to. A sub 1 is the first term, so that'll be 1/9. All right. And r, I got to figure out what r is. Well, how am I turning 1/9 to 1/3? Some of you will have trouble with that. How do you turn 1/3 into 1? Probably the same way you turn 1 into 3. You multiply by 3. 3 to 9, multiply by 3. Check it out. Try 1/9 times 3. 1/9 times 3 over 1. Wonder Woman. And we get 1/3. So you see r is 1/3. That's 9 there. Okay, so r is going to be 1/3. And then it's going to be the 10 minus 1 power. I prefer to think of that as the 9th power, just like that. Now it's very important, do the order of operations, exponents before multiplication. I don't know how many times I have to say that. All right, so I'm going to have this. And I don't know 3 to the 9th off the top of my head. So I am going to go ahead and go to my calculator at this point. 3 to the 9th is going to be a pretty big number. When I multiply by 1/9, it's going to be huge. So I'm going to take the quantity of 1/9. I'm going to multiply it by 1/3. I'm going to raise that 1/3 to the 9th power. Okay? Now, by the way, this is really the same as 1 over 3 to the 11th power. It's the same number. All right. Oh, my goodness, it's in scientific notation. Look at how tiny that number is. Something's wrong. Yep, I know what's wrong. I've made a mistake. That's okay, because r is not 1/3. Yeah, did you catch that? R is not 1/3. I apologize to those of you I might have confused. R is 3, right? Because they're being multiplied by 3. So sorry about that. I'm sure Justine will tell me about it later. All right. And so now we're going to have 3 to the 9th times 1/9. Now, if you're really slick, I'll still go to the calculator on this, but if you're really slick, you might think about a 1/9 as 3 to the 2nd, and then 3 to the 9th. And then you can still do your Wonder Woman thing. You can say, hey, this becomes 3 to the 7th power, right? Because when you divide exponents, you subtract, or divide bases, you subtract the exponents. So the answer is 3 to the 7th. I know that 3 to the 5th is 243. If I multiply by 3, I'm going to get 9 to 729. That would be 3 to the 6th. 3 to the 7th then must be 7 carried to 8. 2187. I think the answer is going to be 2,187, but let's go to the calculator and see what happens. All right, so I'm got too small of a number. Fortunately, you know, I was paying attention to what I was doing, and I'm going to go in here and I'm going to edit this. I'm going to get rid of my fraction, hitting delete, and there we go. So now I have the problem 1/9 times 3 to the 9th, and that's what I wanted. And look at that, I got 2,187. All right, that's it for the actual video. The video quiz is next. Oh, where'd it go? Video quiz. Uh-oh, I lost my page. There it is. There's the video quiz. Now, I'm not telling you which one's arithmetic and which one's geometric, or maybe I'm trying to trick you. Maybe one of them's not. Okay, so test it. If it's arithmetic, if you have the first differences all the same. It's geometric if there's a constant ratio. If things are being multiplied by a fraction, like multiplied by 1/5, or times 4, being multiplied by 4, that would do it too. All right, so you're to determine if it's arithmetic, geometric, or neither, and then you're supposed to find the term. If it's neither, you won't have to find the term, but that's a sub 8, and that's a sub 80. By the way, if you just put down neither for both, and you don't say, well, I don't need to find the term, you're not getting any credit, okay? All right, just so you know, Mr. Laurence signing off. Have a good night, everybody.